is pretty cool.
Got
Like
it.
the reason I asked that because like I do software development and I have like books and YouTubers that I think go specific like they go really in depth in about like a specific topic. So I wasn't sure if you had something that just stood out
Oh,
to you that was a good resource.
I hope I'm writing this right. Yeah, John Kleinberg. Yeah, this is the person. He has a book called, I think this is the one, Algorithm Design, if I'm not wrong. Yeah, this is a pretty amazing book that I have seen. When you talked about this, the first thing that popped up to my mind was this. This is a book that I have seen in prior and I have read in prior, and it's a pretty amazing book to actually figure out problem solving. Um, but more than this book, what helped me most to understand from my idea to work around problem solving is has always been lead code. It's pretty beautiful in its own way. Books will only get you so far to understand and solve problems. However, lead code pretty much comes up with new problems every month, like new problems that you can solve using the knowledge of data structures that you have on a monthly basis. So when they come up with new problems, you can look at all the approaches that you know and try to solve them. They have 1,000+ problems to solve them. So even if you solve, let's say, one or two problems a day, you've got like a year or 2 years worth of content to solve and understand only based on data structures and algorithms. So yeah, lead code problems are a beautiful way to really get into um, data structures and learn about it. You can just list out what kind of data structure you want to use and try to solve all the problems in them if you want. So this is an awesome way to work around it, to be honest. So this is one way that I would highly suggest, just for reference.
Sounds good.
So
Thank you.
anyway, yeah, that I hope that helps out. Thanks, James. And sorry if I got too sidetracked initially on this. So yeah, let's get back onto this. Right. So yeah, that was the main point of making sure that data structures help out a lot, and understanding when to apply what kind of data structure helps us out a huge amount being good developers. So with this idea, let's start with the data structures that are available in Python. There are many data structures available in Python, but there are four major data structures that I'll focus on right now. Those are list, tuple, set, and dictionary. These are the four major data structures that we often see on a day-to-day life, we often use. And yeah, there are a lot of modifications of them. There are a lot of different versions of them. Set has a different version of it called frozen set. There are variety of modifications of these data structures that are available if you go in depth within it. But that's not something we're going to do right now. Let's only focus on these four data structures and try to understand what they are, how they work internally underneath, under the hood of Python, and see how they work around. So yeah, let's get through the first one called list. List is essentially an array indicated with square brackets. That's all it is. So you've got square brackets, and you can enter any amount of elements, any list of elements. You can literally enter any kind of iterable elements within it. So you can have one more list as an element, you can have a string as one element, and the next element can be a number, next element can be a complex number, complex variable, could be anything. The advantage of list compared to arrays in any other programming language is it can store variables of any data type. Now, this is an advantage as well as a disadvantage at the same time. It's a double-edged sword, and I want to first point out why it's a double-edged sword, because we need to know when to use lists and when not to use lists. Especially those who are data analysts or data scientists here who work on, let's say, pandas or polars and so on. You might know the reason why we prefer NumPy arrays compared to lists specifically. So you might know this already, but for those who might not be aware of this, um, here's the advantage and disadvantage of lists. In a list, you can store elements of any type you want, literally any type. The first element may be a string, the second element may be a number, the third element may be a float point, and so on. This is the advantage of it. Now, to understand the disadvantage of it, we need to understand why there were arrays previously in multiple programming languages like C, C++, Java, C Sharp as well, all of these. Why there were concept of arrays particularly, and they didn't move to list, or they didn't move to the idea of multiple data types in a single array. And that's simply because of time complexity. An easy way to understand is a time complexity when it comes down to arrays. Now, starting with this, let's figure out from the basic. Um, let's start with this. Whenever we talk about lists, or let's go back to arrays first. Whenever we talk about arrays, here's how it works. You have a series of elements, all are stored in consecutive memory location. Let's say there's um, again, we're just considering it as characters for reference. And all arrays used to, if it's a character array, it used to end with a character called null character, indicating that this is the end of the string or end of the array. So let's say this is index 0, 1, 2, 3, 4, 5, and 6 for reference. Now, the reason why arrays were useful the way they were is because since this array was of a single data type, I'll just point this out. Since this array was of a single data type, you knew that every element took same um, space. Every element took exact same amount of memory, in other words. So you can take a look here. That is, A took, let's say, 1 byte. B also took 1 byte. C also took 1 byte because they're all of the same data type. When elements are of the same data type, there is primitive basic data type like this. They basically have the same amount of memory. Now, on the other hand, because of this, if you had the starting address, let's say the starting address is 100, then 101, then 102, then 103, then 104, then 105, and let's say 106. If you want to access fifth index, all you had to do is, as long as you knew the starting address, simple, as long as you knew the starting address, you just had to move 5 addresses ahead to get to 105th address. So whichever index you wanted to access, as long as you knew the starting address, you can add so much amount of addresses and you can move that. That was the advantage with arrays. But let's take a look at lists in Python. Here's where lists are different. In list, first element could be a string. Second element could be just a digit. Third element could be a phone number. Fourth element could be a complex number. Now, each one of these are going to take different size, and you should also know what is their data type. This becomes more complex to manage. You cannot just go from one element to another just by knowing, because not every element will take the same size. This might take 5 bytes, this might take just 2 bytes, this might take like 4 bytes, this might take like 8 bytes. Each one might take different amount of size. To overcome this, what happens in Python is it essentially creates an intermediate list like this. It's going to store the following information. Where is the address in which the first element is stored? First element might be stored in address 904. It's just going to say address is 904. And it will also say a store a couple of things. What is the data type, which is string, and what is its length or size occupied, which can be 20 bytes or wherever it could be. So for each element, it's going to store address, data type, and length. Again, address, data type, and length. Same here. Now the problem here is you're going to occupy extra space because you're storing all these additional details, which was not required when you talk about arrays in other previous languages. However, the advantage is you can store elements of any data type you want. So even now, if you want to access the third element, this, I'm so sorry, this size is fixed. Each one might take 4 bytes or 4 bytes or 4 bytes or something like that. So you can directly go to the third element, find out what is the address, go to that address and find out the element. So you can see it's a little bit slower than arrays because in arrays, you go to that space, you will directly find the element here itself. Here, that's not the case. This is why I point out that lists are advantageous and disadvantageous in the same fashion. Lists can store elements of different data types. That's an advantage. Lists can be dynamic in size. You can add X number of elements, delete X number of elements. Its size is dynamic. You don't have to worry about how long a list can go ahead or something. So all of these are the flexibility or advantages that you have in lists. However, they don't take smaller space. They're not memory efficient. Oh, so especially those who might work with data science or data analytics or machine learning, whatever it might be, you might use NumPy arrays to store a series of numbers and not lists. That's because NumPy arrays are typical C language implementation of arrays, and they take lesser memory and they're faster to use. And I will compare and show you how fast they are, which is quite fast. I will show you the difference when we start with NumPy. But now for our understanding, let's just remember this. The purpose of lists are to make sure that you can store elements of multiple data types within it. Now, with this idea, let's go ahead and take a look at the operations of list that we can do and the time complexity that all these operations generally take. All right, so let's start with this. First up, let's start with the very basics. Oh, I forgot to point out one more thing about time complexity. You can take a look at the official website of Python, which is python.org. But here you can go to wiki.python.org. Um, it's a pretty amazing website for you to get all the details and all the things that you want to know within Python. I'll just search here for time complexity, for example, and you have this, and you can see all the time complexity of everything that you can do. So within a list, if you want to add an element, here's the worst case. So yeah, I'm not going to give much info on this. Let's not worry about it. But yeah, this is basically how you get to figure out. So if you want to append, it's 1. If you want to insert, it's 10. If you just want to search an element, where have they specified it? Yeah, in, again, it's n. So all of these are there. This is one thing that you can just take a look at. And this is going to help you out a lot to understand which data structure to use where. So you can see here, to search something within a dictionary, average case is 1. This worst case is not an expected thing, so let's not really worry about it now. We'll see it later. Anyway, let's assume this and begin with this. Right. So to begin with, let's start here. We got to know what a list is. A list is a data structure that can store elements of any data type together. It is dynamic in size, so you don't have to worry about when it reaches its max size or when it does not reach its max size and so on. So that's not something we literally have to worry about, just for our understanding. And yeah, moving apart from that, a few um, other things that we get to see within this are, yeah, basically these common things. So let's continue ahead. And the other part is it takes more memory than typical arrays. Right, now that we know, let's just create a list and begin with this. Oh yeah, and another important thing, lists are mutable. You remember strings were immutable. Now, instead of strings, where strings were immutable, you could not access elements. You literally could not perform operations on strings where you can modify it, right? So anytime you modify a string, you need to literally store it in a different variable. However, in list, you don't have to do that. Lists are mutable, which means whenever you modify a list, you don't have to return some data and store it back like we did with a string. You just perform list dot some modification and it will automatically modify that list. Just something basic we need to know. Anyway, moving ahead from this, let's go on to the next case. Let's start with the basic part of this. Let's create a list like this. Let's say 1, 2, 3, and hello. And if you want, you can keep a list within a list as well. Like again, 1, 2, 3 of it. And let's take 3.14. Perfect. Now you can just print the list as it is. If you run this, you get to, okay, I'm so sorry. I need to run the next file. There we go. You get to print the entire list. Now, on the other hand, you can also perform few other operations on it. I'm just going to start with type of list to begin with. If you run this, you'll get to see it belongs to a class called list. So list has its own class. That's one thing that we need to know. Now, with this idea, let's begin working on lists. Just like before, just like how we saw with the previous operators or previous functions, you can do a lot of things within list, particularly like list of, you can print any index within list. Let's try printing li of 0. We know list of 0 has a value 1. If you run it, it's going to give you 1. Similarly, you can do the same slicing we had done, like 0 colon 4. That should print index 0, 1, 2, and 3. So there we go. You can access the fourth element, list of 4. List of 4 is an other list. So within this list, you can again access the first element if you want. Now let's just remember, in this list, index 4 is a list. So when you access li of 4, you're basically getting this list. Within this list, you can again access index 0, which will give you again 1. So a lot of basic operations like this can be done. So I'll just do IC of li of 0. And let's just import IC for our reference. And there we go. We got some good amount of responses and variables obtained. Now, with this idea understood and with this logic known, let's move on to the next part of this, and let's move on to the next case to work around them. Now, let's start with this. First things first, for us to just figure out here in our case is just let's just remember that lists are, as we know, mutable. Since they're mutable, you can make any modifications with them and save it back in it. So just to give you a scenario, um, okay, before that, let's make sure that we learn all of these and we work ahead. I think let's go one step at a time. Let me just not directly start with that. There we go. Okay, so with a list, you can perform a lot of operations. Let's start with this. With any iterable, you can use in and not in. For example, let's take this. Um, if 3 in list, print found, else print, let's say, not found. So we're just trying to see if the number 3 is available within the list. If it's within the list, we're going to print found. If it's not within the list, we're going to print not found. So if you run this, you're going to have found printed over here. The basic idea is simple. In just searches for a single element within an iterable. Li is an iterable. Within this iterable, we're just trying to search whether 3 is available or not. That's basically all that we are doing. Followed by this, you can do the opposite of it. If, let's say, X not in list, if X is not available within list, let's print not found. Else, let's just print found, for instance. Now, once you run this, the same scenario happens. You get to print not found. That's because X as an uppercase character is not present within the list whatsoever. Just something that we get to see here. A simple way to figure out how to perform operations over this. Now that we know this basic idea, now that we just know how this works to begin with, let's move to the next part. The next part is and is not. So let's take a look at this. Now, I think and we just saw in one of the previous examples, if I'm not wrong, with that credit score. Yeah, and we saw multiple conditions using and operator. So let's not focus much about that. Let's try is and is not. Here's what I'm going to do. Li is equal to 1, 2, and 3. And I'm going to write Li2 is equal to Li. I'm just copying Li to Li2. And I'm just going to write Li. All right, let me print this. If Li is equal to Li2, I'm going to print double equals operator indicates they are equal. Similarly, if Li instead is Li2, I'm going to print is operator indicates they are equal. Now, this does not make sense immediately. I will explain what exactly this is and how exactly this works so we understand this better. Let's run this. Here, okay, let me make it the same here for reference. So you can see here, both indicate they're equal. Here's the problem. There's a big difference between double equals and is. The idea is that double equals compares the content of them. Content doesn't, what is the content of the list? Both Li and Li2 have the same content within the list, exact same content. However, let's try the second condition. The second condition is is. Is does not compare the content. Is compares the address, that is the ID, where they are stored. If one list is equal to another list with is operator, that means both are stored in same memory. So to prove it, I'm just going to print IC of ID of list and ID of list2. If you take a look at this, you can see ID of list is same, ID of list2 is same. Now I have one simple question, one very simple question, which most of you already know the answer to. I'm just gonna make li2. There's a function called append, inbuilt function called append for a list, which will add an element at the end of the list. So for a list, again, for those who might not be aware of this part of or this particular logic of Python, there are dot operators that we use. So whenever you have an object of a class like list or string or anything, if you're not aware of classes and objects for now, please don't worry. We're gonna go through that ahead in time, so you don't have to worry about it right now. So let's take a list dot a function called append. So for this particular list, you're adding an element at the end, similar to what we had as string dot um, we tried strip, right? Yeah. But the difference here is this is immutable. Since string is immutable, any modification you do to it, it's going to return another string, which you have to store. But since lists are mutable, you don't have to store the result in another list. You just have to perform li.append, and that is it. That is enough. It'll just add whatever element you're specifying to the end of the list. That's the major difference. So let's try to take a look at this and work around this. Now, my simple question is this. I'm adding 4 to the end of li2. After performing this, I'm just going to print the ID of li and li2. A very simple question to all of you. Do you think the IDs would be same now or different? We have seen such a question earlier. So, hence, I'm asking you this question. You can take a guess. You can respond either with a text in chat window or however you like. Just take a guess and see what do you think might be the answer. All right. All right. So let's take a look at what happens exactly in this. Now, here is the simple idea. When you run this, typically we expect it to be different because that's what we had in our previous case. If you remember this example that we studied at the beginning or that we looked at the beginning, if A has a value 5, B has a value 5, that means A will point to a memory that is 1000, let's say, which has 5 in it, and B will also point to the same memory location because both of them have the same value available. That's how it works. However, here's the difference. In our current case scenario, if you make B equals B plus 1, since B value is going to change, Python is going to move B to a different location, let's say 1010 or something. This is not the case when it comes down to list. If you have li equals li2, li2 and li will both point to the same list. And whether you modify li2 or li, it will modify the same list. It will not point to a different location whatsoever. Literally, it won't do that. That is the problem with list. By default, it'll become a symbolic link and both will point to the exact same list. So just for our understanding, let's remember when you perform li equals li2, this will make sure that li and li2 point to same memory, even if one list is modified, the other is modified too. So that's basically the idea of list when you assign one list to another for reference. Just for our reference, this is exactly what happens. Now, moving ahead from here, here's what we're trying to do. We are comparing if they're equal in terms of content. Yes, they are, because we copied one list to another. Then we are comparing if they are both having the same address or not. Yes, they have, because we saw that ID of li1 and ID of li2 gave us the same result. And when we added an element, ID of li and ID of li2 both gave the same result again. So just for our reference, if you print li1 and if you print, sorry, just li, it's not li1. If you print li and li2, you can see both of them are modified. And that's essentially how this works when we think about it. That's basically the way lists work. So if you want to copy a list and you want to make another copy to a different memory location, please don't ever do this, because a lot of developers do this and they see that their code is not working as expected. Their code gives errors that are unexpected, and they always try to figure out why is that happening. However, to avoid this, whenever you want to copy a list, instead perform this. li2 equals li dot copy. Copy is an inbuilt function that returns a shallow copy of the list. A shallow copy is a separate copy of it. It returns a new list in a new memory location that is copied from the previous list. That is essentially what happens here in our case. Now, let's move on from this and let's try running this again. This time you get to see, okay, let me comment this out. There we go. Now let's run this. Now you can take a look at this. Since I'm not copying li to li2 without the copy, I'm copying it with the copy function. When you print the ID of them, both are different. You can see ID of the first one. Let me just scroll up a little. Yeah, ID of the first list is 744. The second one is 016. They're both different even before we add anything to it, and they're different after we add anything to it as well. And hence you can make a copy of the list, make modifications of it, so that you don't have to worry about losing content of either lists. So this is one basic thing about lists that we need to know. A lot of us often fail to look into this, and it's just something we need to know and be aware about. Anyway, let's move ahead from here over to the next case. Now that we know the basic idea of list and essentially how it works, let's go on to the next part. We have a few functions within lists that we kind of need to know, we need to learn and understand. So let's start working around that. One more thing that is important for us to know within lists is they allow duplicates. There are a few data structures that don't allow duplicates purely because we saw the hashing logic that we saw earlier. So yeah, that's one thing that we need to know, but we will take a look at that in detail ahead, and we will take a look at that in greater detail to understand it better. Anyway, let's move on to the next case, and let's start with the basic operations that you can do, let's say within lists. Now, to perform these additional operations or perform these operations ahead, we're going to take a small example of some treats, for example. So I just want you guys to just type out any treat that you might like, for instance. I'm just going to type something like s'mores, for instance. But yeah, I'll just ask you out of a curious example to just write out whatever treats you feel are something that you might like. Just over the chat window, we'll just add it and we're going to perform some fun little operations on it. So you can pick any that you'd like. It's just a random example that we're taking up, nothing else apart from that. Meanwhile, I'm just going to add a couple in case I might not get a response immediately. I'll just add a few for reference. Again, purely taking random examples for our understanding, and we're going to have some fun with these examples. And I'm terribly sorry if anyone might be hungry and I'm taking these examples. It seems, yeah, please bear with that. Okay, Baron, that's unfair that you stole a Snickers from a kid. That's unfair. So, yeah, let's take ice cream. I'm not sure whether it's the treat that you're pointing out or the package, but it's fine. We'll take this up. And let's take Snickers. So perfect. I think this should be good enough for a very small example. I'm going to take a lengthier one for reference. Let's take Ferrero Rocher. This should be good enough. Yeah, I think we have good enough list of treats over here. Perfect. Right, so let's go ahead and start working on these. So the first thing I'm just going to do is try to print them. We get to print this entire list of treats available. Now, there are a few things that you need to know about lists particularly. We know that we can insert an element at the end of the list by using append. I can use treats dot append of let's say I'm lost for words here, so I'm just gonna take um, matcha green tea or something like that. Probably because I had it yesterday and that's the first thing that came to my mind. So let's just take this for reference. The idea of append is it adds an element to the end of the list always. Hence, you don't have to specify an index. It directly adds to the end of the list. And if you print, let's say, treats here, you get to see. Oh, yeah, and one more thing. Since we are printing it with ice cream automatically tries to limit the length. So if the length is quite large in terms of the list, it tries to print it in an orderly manner so you can read them in an easier and understandable way. That's just one thing that you need to know about it. Anyway, so yeah, this is one way to add an element to the list. Now, since we have added an element to the list, let's try to remove that element from the list as well, because we've added one. Let's try removing it. To remove it, a fairly simple idea, you just have to use treats dot to remove of whatever is that exact value. That is matcha green tea. And I'm just going to specify it as remove the value or remove the item from the list. Now, here's the problem with removing item from the list.